cracking WPA or WPA2 encrypted networks, it's not simple, especially that all the packets that are sent into the air are not useful for us, as they do not contain any information that can help us determine the WPA key. Before we get into cracking WPA and WPA2, there is a feature called WPS. It allows users and clients to connect to the network by a push of a button. So on Windows 8, and if you look on some Wi-Fi printers, they have a WPS button. So if you press that WPS button and you go to your router and press the WPS button there as well, or go to the configuration page and press the WPS button, the client, the printer or your Windows device will connect to the network without having to enter the key. So the purpose of using WPS, it's a feature that allows clients to connect to the network easily without having to enter the WPA key manually. So it's just a feature in routers. This feature works and authenticates the client based using an 8-digit long PIN. So it doesn't use the actual WPA key, it uses an 8-digit PIN. This is only digits, and it's only 8 bits long, so there isn't too many possibilities for this. And if we use a brute force attack, we are guaranteed to guess this pin. If we successfully guess this pin, then we can use a tool called Reaver, which would calculate the WPA key from this pin. So we're going to brute force the pin, the 8-digit long pin. Because it's only 8 digits, we're guaranteed to be able to brute force it successfully. Once we do that, we can calculate the WPA key using Reaver. Again, this is only a feature in routers. This flaw is not in WPA or WPA2 encryption. The problem is in the WPS feature. So let's see how we do this first. To look for access points that have WPS enabled, we're going to use a tool called Wash. So I'm just going to put Wash I10. So we have our test AP showing up here. That's the AP that we're going to use to crack. So this is actually running on WPA now. It's not using WIP as we saw in the previous videos. I can confirm that for you here. I'm just going to use arrow dump. This step is not important. I'm just going to use it to show you that test AP is actually using WPA encryption. It's not WEP. So as you can see here, test is using WPA encryption. Let's just go back. So these are the access points that have WPS enabled, that have the WPS feature enabled. We can see the channel, the RSSI, which is the distance between us and the access point, the WPS version, and this WPS locked. Now, some routers, when you try to brute force the WPS pin, they lock after a few failed attempts. So if you try, for example, 4 wrong pins, they're gonna lock and not accept any pins for a certain amount of time. So if the WPS locked says yes here, then you can't actually use this attack now. So you need to wait for a little bit and come back to this access point. So we're gonna launch Reaver now. Reaver is going to brute force the WPS pin, and once it's able to find the WPS pin, it's going to work out the WPA key. Reaver supports pause and resume. So if you for example brute force 30% of the possibilities and cancel the attack, if you come back, you're gonna start again from 30,000. You're not gonna start from 0. So let's launch Reaver. We're gonna put B to choose the BSS ID or the MAC address of the target access point, and then C to choose the channel, which is 11, and then I and choose the Wi-Fi card with monitor mode, and that's 10. So very simple. Reaver, access point, BSS ID, channel, and then the Wi-Fi card with monitor mode. Gonna hit enter, and now Reaver associated with the target access point. It tried to determine the WPS pin. Now I have an easy pin, which is 1, 2, 3, 4, 5, 6, 7, 0. And from that, it was able to calculate my WPA key. So that's the WPA key, UAU RWS XR. And that's just the name of the access point. So I can just come now and connect to my network. And if I put the key that we just found, I'm going to show the password, and it's UAU RWS XR, connect. And as you can see, we connected successfully to the network. Now there's a few options that I'd like to show you for Reaver. I'm just going to go Reaver, help. And that's all the options that you can use with Reaver. So, as I said, some routers would lock after a few failed attempts. Therefore, you can use some of these advanced options to get Reaver to work against these access points. For example, you can use the delay option and specify the amount of time in seconds that Reaver should wait between each brute force attempt or each pin attempt. You can also use the lock delay to tell Reaver to wait, for example, 60 seconds after if the access points gets locked, then wait for 60 seconds and then continue your brute force attempt. You can use the fail wait as well to set the time that Reaver should wait after 10 failed attempts. You can use the OR option to tell Reaver to sleep after a certain amount, to sleep for a certain amount of seconds after a certain number of tries. You can set up the timeout. You can play with these options, the delay options, and the timeout, the fail wait, and all that if the access point was locking or was ignoring some of your brute force attempts.